Okay, here we are, Stats and Mechanics, Year 1, Chapter 10, Question 10. Motoring through. Right, a car is towing a trailer along a straight horizontal road by means of a horizontal tow rope. The mass of the car is 1,400 kilos. Okay, so we've got a trailer, we've got a car, and it's all coming along the road. And they just told me that the mass of the car is 1,400. Okay, kilos, good. The mass of the trailer is 700 kilos. The car and the trailer are modelled as particles, and the tow rope is a light, inextensible string. Good, that makes it easier. The resistance to motion of the car and the trailer are assumed to be constant, and a magnitude of 630 and 280 respectively. The resistance to motion of the car is 630. Okay. 630, and the resistance of motion to the trailer is 280. Okay. Should be constant magnitude respectively. The driving force of the car due to the engine is 2,380. Going in this direction, 2,380 newtons. Very good. Find the acceleration of the car. Okay then, let's have a little look. So the acceleration of the car and the trailer and everything is all connected and all the same thing and can be considered to be the same thing. Okay, so if we set up F equals MA, we should have 2,380 minus the 630 minus the 280 is equal to the mass of 1,400 plus 700 times A. So 2,380 take away 630 take away 280, that gives me 1,470. 1,470 being divided by 2,000 for the 1,400 and the 700. That's not right, that's 1,100. It should be equal to the A, 2,100, which is 0.7 meters a second minus 2 is equal to A. Okay. So, the tension in the tow rope. Okay, so the tension in the tow rope is going to be the same forwards and backwards. Okay, so now we can look at the acceleration of the car, or the F equals ma of the car, separately. So if we do F equals ma, but we consider only the car this time, we've got 2,380, take away the 630, take away the tension force, is equal to the mass, 1,400, times 0.7, the acceleration. Okay, and so when we start putting that in, 2,380, take away 630 is 1,750. 1,750 take away t is equal to, what's 0.7 of that? 980. 980. So 1,750 take away 980 is 770. So the tension, when you rearrange that, is 770 newtons. Okay. When the car and trailer are moving at 12 meters a second, the tow rope breaks. Oops. Never done that before. Yes, I have. Alright, the tow rope breaks, assuming that the driving force of the car and the resistance to motion are unchanged. Okay. Find the distance moved by the car in the first 4 seconds after the tow rope breaks. So, when the tow rope breaks, we only have a car, and it's still got 2,300, was it? 2,380 newtons going this way. It's still got 630 newtons going this way. A 1,400 mass. Okay. And when the car and the trailer moving, assuming that the driving force of the car and the resistance to motion are unchanged, find the distance moved by the car in the first 4 seconds afterwards. But the acceleration has changed at this point. So quickly do F equals ma again on this to get 2,380. Take away the 630 is equal to 1,400 times A, 2,380. Take away the 630. Yes, it was the 1,750 being divided by 1,400 will give me the acceleration divided by 1,400, which is 1.25 meters a second minus 2. Now that I've got the acceleration, I can think about suvat in this case. The distance we are looking for, they told us that the initial speed was 12 meters a second. The final, I don't know. The acceleration we just worked out, and they said 4 seconds. So, jumping around to your suvat equations, something with S but no V in it, so that is going to be S equals ut plus a half at squared. So the distance will be 12 times 4 plus a half times 1.25 times 4 squared. Okay, and so we end up with 12 times 4 plus 0.5 times 1.25 times 16. Okay, 58 meters. Okay. Right then. State how you have used the modeling assumption that the tow rope is inextensible. How have I used inextensible? All right. So, inextensible. How do you spell that? Simple tow rope will mean that the acceleration of the car and trailer how do you spell trailer and the trailer are, I think will mean that the acceleration of the car and the trailer are the same. Okay. Yeah, that's it. They're just the same. All right. Acceleration of the car and trailer are the same. and the tension is the same. Okay, which is what we use doing the calculation. Tension. All right.